All right, so check this out, right? I was just scrolling online the other day and stumbled across this debate, this like heated debate, and you are never going to believe what it was about.
Let me guess. Politics.
Nope. Even better?
Math.
Math, really? Yeah, it was one of those order of operation problems, like the ones that take you right back to middle school.
Oh, I see. It never ceases to amaze me how a concept that seems so simple can spark such passionate disagreements online.
I know, right? And the thing is, we all remember PEMDAS, right? Or bold mass or whatever acronym you learned. But still, people were like absolutely convinced that their way, the way they remembered it, was like the only right way.
What I find fascinating is how often those mnemonics, while definitely catchy, lead to these misunderstandings. We think we're good, we're set with our, please excuse my dear Aunt Sally, but then we get an answer that's totally off.
Okay, so for this deep dive, we are tackling order of operations. We've got blog posts, podcast episodes, you name it, all sorts of perspectives on why this basic math concept causes so much confusion.
And, it's way more interesting than you might think.
Oh, absolutely. Yeah.
Because, let's be clear, having a consistent order of operations, that's not just some arbitrary rule.
Oh, right, of course.
It's fundamental to how we communicate mathematical ideas.
Yeah. It's like needing one of those universal adapters so your ideas can plug in anywhere in the world, right?
Right,
Math needs that shared language, that common ground, or else things just get messy.
precisely. Imagine someone like Descartes, right? Hundreds of years ago, trying to express his groundbreaking mathematical concepts, he needed that shared structure, that clarity, or his ideas wouldn't have been understood and built upon.
Right, so we've got these order of operations, this common language for math. But if it's so simple, why all the online brawls?
Well, it really often boils down to those mnemonics. As catchy as they are, they oversimplify things, and that creates a few critical misinterpretations.
Okay, so what are we getting wrong?
For one, a lot of people come away thinking multiplication always comes before division, no matter what. Same for addition and subtraction, all because of PEMDAS.
So Aunt Sally is leading us astray.
Exactly. In reality, you tackle multiplication and division from left to right as they appear in the equation, and then you do the same with addition and subtraction. Some people try to fix this with other mnemonics. I've even seen GEMA, but the same problem kind of pops up.
It's like putting a Band-Aid on a cracked phone screen.
Yes.
Might look a bit better, but it's not fixing the real issue.
Right, precisely. And that's where those tricky examples from the sources we look at come in. One blog post highlighted this equation. 4.3 plus 10.55 as 2. Now, if someone were to follow PEMDAS rigidly, they'd probably arrive at 0.
Okay, I see. But if we follow the actual order of operations, carefully working through the division and multiplication from left to right first, and then tackle the addition and subtraction.
You get the correct answer, which is 5.
Wow, 5. Who knew such a little equation could cause such a stir?
I know, right?
And this is just the tip of the iceberg, right?
Absolutely. These mnemonics, they make it seem like the order of operations is just this random set of rules, something to just be memorized. But the truth is way more interesting.
Let's hear it.
This order, it's not random. Not at all. What's fascinating is that it reflects a deeper inherent structure within math itself.
Okay, now this is getting interesting. Tell me more.
Think of it this way. There's a sort of power ranking of operations. So parentheses come first, right? They're
Right.
essentially creating their own little world within the equation.
So they're like the VIPs of the math world.
Exactly. And then we move on to exponents. Remember, exponents are all about repeated multiplication.
Right.
So they're already a level up from your basic addition and subtraction.
So if multiplication is like a power boost, then exponents are going Super Saiyan.
Exactly. They carry more weight, so to speak, than simple addition or subtraction.
Mm-hmm.
And then we get to multiplication and division. And as we've said, those are two sides of the same coin, and both a step above addition or subtraction.
Okay, so I'm starting to see this hierarchy play out here, but for someone who's trying to learn this stuff, it's easy to get bogged down in these acronyms. But you're saying there's a deeper logic here.
Absolutely. Understanding that inherent logic is key to truly mastering the order of operations. It's not about memorizing a random sequence of steps. It's about recognizing the inherent relationships between different operations.
So it's like learning to cook, right? You can follow a recipe to the letter, but it's understanding the why behind each ingredient, how those flavors interact. That's what makes you a chef.
A perfect analogy. And speaking of relationships, this is where we get to those sources talking about additive versus multiplicative reasoning. These different ways of thinking about numbers actually play a key role in why the order of operations is structured the way it is.
Yeah, I saw that phrase a couple of times, that additive versus multiplicative reasoning, and I gotta admit, I wasn't totally clear on what that meant. Could we maybe, break that down? Of course, of course. Simpler than it sounds, I promise. Imagine you're, cutting a cake into slices. So that's division, right? It's a multiplicative concept.
Right.
Now imagine taking some of those slices and, adding them to your plate. That's addition, an additive concept.
Yeah.
So basically, multiplicative reasoning, that's about thinking in terms of groups, proportions, while additive reasoning is about combining, taking away individual amounts.
Okay, so I see. So how does this connect back to our order of operations?
Well, think about it. Multiplication and division, those multiplicative concepts, they're kind of a level up from addition and subtraction.
Right.
They deal with these groups and proportions, which are inherently more complex than simply adding or subtracting single amounts.
So it's not just about the operations themselves, but about the kind of reasoning behind them. Okay, this is making those seemingly random PEMDAS rules start to make a bit more sense, I've got to admit.
Exactly. And remember how we touched on fractions earlier?
They fit right into this framework. Fractions, they're inherently tied to multiplicative reasoning. They're representing parts of a whole.
Okay, that makes sense. Now, you're probably thinking, listening to all this, there has to be a better way to teach this. And
Yeah.
and actually, some of those sources we looked at offered some interesting alternative approaches. One that stood out to me was this idea of open middle problems.
Yes, those are fantastic.
They're cool, right?
Uh,
They feel almost like a game.
They are.
So, for example, one of the podcast episodes I read described a problem where you've got 5 blanks and the numbers 1 through 5.
Okay.
Yeah, you have to use each number once, right? Along with different operations to try to get the highest possible results.
Right, right.
But here's the thing. You can only use each number and each operation one time. Talk about a brain teaser, right?
I know. And it's great because what it does is it forces you to think critically about the placement of those operations and how those choices impact that final outcome.
Yeah, it's not enough to just memorize PEMDAS anymore. You've got to understand how it all works together.
Yes, and these problems, they encourage flexibility, experimentation. It moves away from that rote memorization towards genuine understanding.
It really is a cool approach. And that's kind of the beauty of these alternative approaches, right? They're not just about, getting that right answer, but they're about exploring that why behind the rules, making these connections that really stick with you.
Yes, it's about shifting from memorization to genuine understanding, like we were talking about.
Okay, so we've gone deep, deep into the world of PEMDAS, uncovered its flaws, explored this deeper logic of the order of operations. So, what's the big takeaway here? What do we want our listeners to, walk away with after this?
Well, we started this whole deep dive talking about how crucial the order of operations is for clear communication in math.
It's like math's universal language, right? It makes sure that we're all on the same page.
Exactly. But what I find so interesting is how often even these seemingly simple problems, like the ones we've been discussing, can still spark debate.
I know. It's kind of humbling, isn't it? It's like, even in the world of math, which we think of as so black and white, things aren't always cut and dry.
Right. And perhaps those debates, maybe they highlight something else, something really crucial about how we approach math in general.
Okay, tell me more. I'm intrigued.
I think perhaps we get too caught up sometimes in the rules, the procedures.
Yeah.
Like clinging to PEMDAS without ever really questioning the why behind it.
It's like trying to, I don't know, learn a new language, but you only memorize grammar rules. You never actually, try to have a conversation.
Exactly. You might be able to conjugate verbs in your sleep,
Yeah.
but can you actually have a conversation?
Sure.
Can you grasp the nuances, the beauty even of the language?
So instead of just memorizing PEMDAS, we need to, think bigger. Think about the logic behind those operations, right?
Yes. And I think that leads us to a thought-provoking question for everyone listening. Think back to your own experiences with math. Was it about rote memorization for you, or was it about genuine understanding?
Did you feel like you were unlocking a secret code? Or were you just trying to get that right answer without really, knowing why? Because at the end of the day, math isn't just about finding the answer, is it?
Not at all. It's about understanding the journey. It's about the logic, the interconnectedness of it all.
It's about seeing the elegance, the beauty even, in how it all works together.
So the next time you encounter a math problem, don't just, immediately reach for that PEMDAS crutch. Take a moment. Really dive a little deeper. Explore the relationships at play. You might be surprised by what you find.
You might even find yourself, kind of enjoying the journey. Thanks for joining us for this deep dive into the fascinating and sometimes frustrating world of the order of operations.